Have you ever noticed how your AI assistant can write this beautiful, complex poem about the cosmos, but then it just completely fumbles a super simple question? Well, we're going to dive into some fascinating research that explains exactly why that happens, and more importantly, how AI is finally learning to move beyond just knowing things to actually doing things.
It is a frustration we've all felt, right? You ask your chatbot what seems like a totally basic question, and the answer comes back sounding super confident and is completely, utterly wrong. And look, this isn't just some weird quirk. It's a fundamental limitation of how most of these AI models are built. But what if we could teach them not just to guess, but to actually find and use the right tool for the job?
Okay, so this slide just nails the whole problem and the solution in one go. On the left, you see the standard AI's approach. It's just guessing, right? It's looking at patterns of words it's seen before, and it gets it wrong. But on the right, you see the new approach. Here, the AI's brain is connected to a tool, in this case, a little code interpreter. So instead of guessing, it uses the tool to get the correct answer. This is the huge leap from being a probabilistic parrot to a real problem-solving agent.
All right, so to really get why this shift is such a massive breakthrough, we first have to understand the core limitations we're trying to solve here. Let's pop the hood and take a look at the surprising blind spots that even the most powerful AI models have right now. This really breaks down the core weaknesses. First up, their knowledge is static. It's basically frozen in time, like a photograph of the internet from a year or two ago, so they have no idea what's happening right now. They're also, and this is kind of funny, really bad at precise math. Then there's the whole hallucination thing, which is just a fancy way of saying they confidently make stuff up. And finally, they're trapped in this world of text. They can't just reach out and use a calculator or do a live web search. Okay, so you've got all these problems. The first logical step researchers took seems pretty obvious, right? If the AI can't do something on its own, well, you just need to give it the right set of tools. And that's exactly what they did. Developers started hooking up these massive AI brains to external tools. Giving them access to a search engine for up-to-the-minute info and a code interpreter that can act like a super powerful calculator. Problem solved. Or maybe not.
Yeah, as it turns out, just handing over a toolbox isn't quite enough. The AI also has to build the actual skill of knowing how and when to use each tool. And that, my friends, brings us to the real challenge.
This quote from the research paper just hits the nail on the head. The really hard part isn't just giving an AI a tool. It's teaching it the skill to weave that tool use seamlessly into its own thinking process. When should it stop trying to reason and just go search for a fact? When should it use a calculator instead of trying to guess at the math? You see, the first attempts at this were, well, they were pretty clumsy. An AI might get stuck in a loop, searching for the same thing over and over and over again. Or it might try to use a search engine to solve a math problem. It was like giving a brilliant but totally inexperienced apprentice a full set of power tools. All the potential was there, but the skill and the judgment were just missing. So, how do you fix that? How do you turn that clumsy apprentice into a master craftsperson? Well, this brings us to the breakthrough at the heart of this whole thing, a new training method called TAPO. TAPO. It stands for Tool-Augmented Policy Optimization. Now, instead of just showing the AI a bunch of examples, this is a training framework that lets the AI learn by doing. It's designed to build the actual skill of tool use, teaching the model to have an instinct for when to think, when to search, and when to calculate.
So how does it actually work? Honestly, the best way to think about it is like you're teaching a dog a new trick. First, the AI tries to solve a problem. Then, its answer gets automatically scored. If it made good choices, like, say, using the calculator for a tough math problem, it gets a little reward, like a treat. If it made a mistake, no reward. After doing this thousands and thousands of times, it starts to learn the best strategy, refining its instincts until using its tools just becomes second nature. Okay, so that's the theory. But does this new training method actually work in the real world? Let's dive into the results and see how a TAPO-trained AI stacks up against a standard one. Check this out. This slide is a fantastic example of how TAPO beats that whole static knowledge problem. On the left, a standard AI with its knowledge cut off in 2023 is asked about something that happened after that date. It can only give you old info. But the TAPO-trained model on the right is smarter. It knows its internal knowledge is out of date, so it intelligently uses its search tool to find the correct, up-to-the-minute answer. That ability to go check for new information is an absolute game changer for reliability.
And the numbers? Wow, they tell an even clearer story. When researchers tested a standard AI that was just given access to tools, it scored about 40% on a complex set of problems. But after it went through TAPO training, its performance shot up to over 60%. That is a massive leap in its overall ability to solve problems.
And on tasks that specifically required a calculator, that classic AI weak spot we talked about, the TAPO model achieved a staggering 98.6% accuracy. It has effectively eliminated one of the most common and frustrating ways that large language models fail. So it's not just a little better, it's near perfect where it used to be the worst.
But it's not just about getting the right answer. It's about getting there efficiently. Check this out. When asked a question, a less advanced model might find the right info on the first try, but then, as you can see on the left, it just repeats the exact same search, wasting time and energy. The TAPO model on the right is way smarter. It does one clean search, gets the answer, and stops. It's learned not to waste its own time.
So, these results are obviously impressive, but what does it all really mean for the bigger picture? Let's zoom out for a second and think about what this means for the future of AI and why it should probably matter to you.
At the end of the day, this isn't just about scoring higher on some academic test. This research is a critical step toward the kind of AI we've all really been promised, an assistant that you can actually rely on, one that doesn't just guess, but knows when it needs to go check its facts, one that doesn't make silly math mistakes, an AI that's less of a novelty and more of a genuinely useful tool in our lives.
And that leaves us with this one big final thought to chew on. For years, we've been focused on making AI bigger and bigger, but this research really shows that maybe the future is about making it smarter, more capable. So, if an AI can learn to use digital tools with the same skill and intuition as a person, what new, complex, and incredible problems are we finally going to be able to solve?